Hello everyone, welcome to my channel. Keep exploring. In today's video, we are going to discuss exercise 2.1 of the chapter Polynomials Class 9. Before we start the exercise, let's go through some basics. Polynomials in one variable. As you can see here, x cubed minus x squared plus 4x plus 7 is a polynomial in x. So this is a polynomial in one variable and that variable is x. As we see that there is no other variable than x. So that is the only one variable present in this polynomial. So these polynomials are called as polynomials in one variable. Few examples you can see here. 3y squared plus 5y. This is a polynomial in the variable y, and t squared plus 4 is a polynomial in the variable t. So here we see that in the first polynomial we have only x, in the second we have only y as a variable, and in the third one we have only t as a variable. So these are polynomials in one variable. Now let's see about the terms and coefficients of a polynomial. So we say that in the polynomial x squared plus 2x, how many terms are there in this? The expressions x squared and 2x are called the terms of the polynomial. As we know that in a polynomial, the terms are separated using a plus sign. So these are the two terms in this polynomial. Similarly, if you take another polynomial, 3y squared plus 5y plus 7, in this it has three terms, that is 3y squared, 5y and 7. Now we know that each term of a polynomial has a coefficient. So in minus x cubed plus 4x squared plus 7x minus 2, let us consider this polynomial. The coefficient of x cubed will be minus 1. We know that if there is no coefficient, so we will treat it as 1. So the coefficient of x cubed is minus 1 and the coefficient of x squared is 4. Coefficient of x is 7. So here when we talk about coefficient, it's just a numerical coefficient. And the last one, here minus 2 will be the coefficient of x to the power of 0, as we know that x to the power of 0 is 1. So minus 2 can be written as minus 2 multiplied by 1, and 1 is nothing but x to the power of 0. So minus 2 is the coefficient of x to the power of 0. Now let's see which are not polynomials. So which algebraic expression are not polynomials? What is the condition for that? Now consider the algebraic expression x plus 1 by x, root x plus 3 and cube root of y plus y square and so on. So we know that 1 by x is nothing but x to the power of minus 1. Here the exponent of the second term is minus 1, which is not a whole number. So this algebraic expression is not a polynomial. So we know that for an algebraic expression to become a polynomial, the exponent of the variable must be only a whole number. It cannot be a rational or negative. It cannot be a rational or negative exponent. Similarly, root x plus 3. So root x is nothing but x to the power of 1 by 2 plus 3. So here the exponent of x is 1 by 2. So 1 by 2 is not a whole number. So this is also not a polynomial. Next, depending upon the number of terms in a polynomial, we have given some names that are monomials, binomials and trinomials. If a polynomial has only one term, it is called as monomial. If a polynomial has two terms, that is a binomial. And if a polynomial has three terms, it is called as trinomial. So here a thing you have to note that all comes under polynomials. So polynomials, if it has one term, monomial, two terms, binomial and three terms, trinomial. As you can see the examples. Moving on, degree of a polynomial. Degree is nothing but the highest power of the variable in a polynomial. The highest power of the variable. So in this polynomial, 3x to the power of 7 minus 4x to the power of 6 plus x plus 9. In this we see that the highest power of x is 7. So 7 is the degree. Similarly, 5y to the power of 6 minus 4y squared minus 6. In this, the highest power of y is 6. So 6 will be the degree. And one more thing we should to note, the degree of a non-zero constant polynomial is always 0. For example, 5. 5 is a non-zero constant polynomial. So 5 can be written as 5 into x to the power of 0. So here we say that the degree of this non-zero constant polynomial is 0. Basing on the degree, we have again classified polynomials into linear, quadratic and cubic. So what is a linear polynomial? If the degree is 1, it is a linear. As you can see here, 5x plus 6, the power of x is nothing but 1. So it is a linear. For a quadratic, the degree is 2. So the highest power is 2. So this is a quadratic polynomial. And if the degree is 3, the highest power is 3. So this is a cubic polynomial. So based on this, we will be solving now exercise 2.1. So the first question says, which of the following expressions are polynomials in one variable and which are not, and state the reasons for your answer. So let's see. The first bit says 4x squared minus 3x plus 7. So it is clear that this is a polynomial in one variable because only x has been used. So this is a polynomial, and see that all the powers of x are whole numbers. So this is clearly a polynomial in one variable. The next one, y squared plus root 2. Here also this is a polynomial in one variable as the power of y is 2. So this is a whole number, so it comes under polynomial, and only one variable has been used. That's why it is a polynomial in one variable. Moving on to the third bit, 3 root t plus t root 2. So root t is nothing but t to the power of 1 by 2 plus t root 2. So here we see that one of the power of t is 1 by 2, and 1 by 2 is not a whole number. Since it is not a whole number, this is not a polynomial. Although only one variable is used, still it is not a polynomial. Similarly, the fourth bit, y plus 2 by y can be written as 2 into y to the power of minus 1. Here also, it is not a polynomial because the power of y here is a negative number. So we cannot take negatives for polynomials. So this is also not a polynomial. The last one, x to the power of 10 plus y to the power of 3 plus t to the power of 50. Although all the powers are whole numbers, but here this is a polynomial in three variables. It is not a polynomial in one variable. Next, write the coefficients of x square in each of the following. The first question, 2 plus x squared plus x. Here we see that x squared, the term x squared has coefficient as 1, as nothing is required. X squared is nothing but 1 into x squared. So the coefficient of x squared will be 1. Next, similar 2 minus x squared plus x cubed. So here the coefficient of x squared is minus 1, as x squared will be written as minus 1 x squared. So the coefficient of x squared is minus 1. Next, here the coefficient of x squared is pi by 2. The coefficient is pi by 2. The last one, root 2x minus 1. Here the coefficient of x is root 2. But the question is, what is the coefficient of x squared? As we see that there is no x squared term, so we can write it as 0x squared. Here the coefficient of x squared will be 0. Next, give one example each of a binomial of degree 35 and of a monomial of degree 100. So since we want a binomial, so a binomial will have two terms with some operators plus or minus. So give one example each of a binomial of degree 35. Degree 35 means the highest power must be 35. So if we write x to the power of 35 plus 5 or x to the power of 35 plus x squared or x to the power of 35 plus x to the power of 30 also. Here we see that in all the cases the highest power is 35 and it contains only two terms, so it is a binomial. Next, monomial. Monomial means only single term. So, and the highest degree is 100. So, the degree is 100. So, highest power is 100. Other than 100, we cannot use any of the powers. So, it can be x to the power of 100 or y to the power of 100 or even z to the power of 100. The degree is 100 and it is of single term. So, these are all monomial of degree 100. Next, write the degree of each of the following polynomials. So here we know that degree means the highest power of the variable in that polynomial. So in the first bit we say that 5x cubed plus 4x squared plus 7x. Here the highest power of x is 3. So here the degree will be 3. Second bit, 4 minus y squared. So there is only one y, that is y squared. So the highest power is 2. So the degree will be 2. In the next bit, 5t minus root 7. Here the highest power of t is 1. So degree will be 1. And the last one, only 3. So 3 is a non-zero constant polynomial. Here the degree will be 0 because 3 can be written as 3 into x to the power of 0 or y to the power of 0, anything. So here the degree of a non-zero constant polynomial will be 0. Next, classify the following as linear, quadratic and cubic. So earlier we have seen what is a linear, what is quadratic and what is cubic polynomial according to the degree. So here in the first case x squared plus x, the degree is 2. So this is a quadratic polynomial. In the second case x minus x cubed, the highest power is 3. So this is a cubic polynomial. The degree is 3. So it is a cubic. The third bit, the degree is 2, so it is quadratic. 1 plus x, the degree is 1, so it is a linear polynomial. 3t, can be written as t to the power of 1, so the highest power is 1, that is the degree 1, so it is also a linear polynomial. R squared, the degree is 2, so it is a quadratic polynomial. The last one, 7x to the power of 3. 3 is the degree. So this is a cubic polynomial. That's it. Thank you for watching.